I'm very happy to welcome a very distinguished speaker for today. It's Dr. George Vanasek from Future Way Technologies. Dr. Vanasek has a very distinguished record of accomplishments, including several startups and working on very exciting leading edge technology, including cloud computing. So I stop here and leave the floor to our speaker.
Thank you. So before I start, I want to say I'm glad to be back at Purdue again after so many years. I don't want to admit how many years I've been here, but I was both a student and a faculty member. And I've also been back to hi some of my colleagues right here that I worked with back in the early 90s. So I'm here to tell you about some of the work I'm doing at FutureWay. In our innovation center, and tell you about some of the projects that are related and why this is so important. Before I get into it, let me start by saying that trust, as you probably know, is a very personal and human trait that is quite complex, and I will not do it justice from the cognitive and social sciences point of view. However, I'm here as a computer scientist, and I'm trying to basically bridge what cognitive scientists and computer scientists have been working on for a very long amount of time to try to formalize trust and impress on us that it is time that trust becomes an important paradigm shift in the future internet. So I'm going to structure the talk around some very basic sections. Before I start, I really have to tell you about Huawei. Most of you don't know anything about it, as I didn't myself 2 years ago. And then quickly jump into why it is so important that we start thinking about what the future cyberspace will look like, and define a little bit of the paradigm shift that ought to take place, as well as the trust formalization that we would need to institute in order to make that happen. And then leave with some departing thoughts, observations, and some open problems. So before I start on the trust issue, let me quickly introduce you to Huawei. And you can read what's on the board. Let me say that 2 years ago I was working for an international company out of Netherlands called Cordis, doing business process management, doing some complex solutions for telecommunication providers. And as happened several times in the past, I get a call from one of my colleagues and saying, it's time for you to come back and work on some really hard problems or interesting problems. And so before I knew it, I was back in Santa Clara in Silicon Valley, working with some of my old-time colleagues from all over the industry, from Cisco and Motorola and even Amazon, VMware, people coming together in this new environment underneath this new owner called Huawei, to be part of a new center in Silicon Valley that was uniquely positioned to bring together a representation from every known business unit and lab in Huawei in a single place, to sort of absorb the Silicon Valley culture of innovation and looking at disruptive technologies, and really start to foster some leading edge work to help the company compete in the markets. As you can see, Huawei, it is a Chinese company out of Shenzhen. We have representation all around the world. And what most people don't realize is that it is providing some of the telecommunication equipment to 45 out of 50 of the top telecommunication providers in the world, and it's just growing phenomenally. But what's important about it is that I used to work for Bell Labs back in the 90s, back at a time where we could do some long-term research without being tied to short-term product lines, and some of that spirit is now kind of re-emerging within Huawei, especially within our Santa Clara Center. And if you look at the company, 10% of its investment is in R&D, and almost 50% of the people are involved in R&D. So there's a huge amounts of innovations, and nowhere can you see that more than in the product line that the company is offering. I know this font is a little bit small, but Huawei is the world's second largest telecommunications provider, especially in the mobile space, having a complete solution. And I mean, when I say complete solution, I mean we can build out everything from the fiber, the microwave towers, to embedded technology, these lamps, everything, all the way up to the services running in cloud computing. And now more and more you're going to go to Best Buy and find Huawei smart devices and Android phones that are competitive with the likes of iPhones and Galaxies and others. So Huawei is, quickly has came out of nowhere, and it's now a $30+ billion company and growing at about a 20% rate. So it's really an exciting place to be in terms of innovation. It's quite good. So with that said, why do we need trust in the digital world? There's a number of major trends that have been brewing on the horizon, and if you've been in the industry long enough, you see these cycles that a lot of times came and disappeared because the technology wasn't there or the market wasn't there. And we're at a point now where there's so much innovation, there's so much growth in the technologies that things that were not possible before are being brought in together in a way that is absolutely changing the world. And so, trust is, as I point out here, is something that has been, humanity's, most explicit and intrinsic social, cognition, in the sense that we all understand it. It's very tangible. We deal with it every day, and yet it has been, for the most part, hidden and burned into these data silos and corporate security solutions without giving us much control. And as I'm going to describe now, it is one of the missing ingredients to really solve a lot of the future problems dealing with the balance between security and privacy. So to get an appreciation for that, we have to look at some major global trends. One of them is the growing digital intelligence. As you all know, I was here at the beginning with Buster Dunsmore and a bunch of people. I remember working at NIST and meeting Mark Andreessen and Tim Berners-Lee, who were just nobodies at that point, preaching web and talking about hyperlinks and XML or HTML at that point, and it wasn't really clear where it's all going to go, and yet it has changed the world. Went from a lot of the Web 1 web server content delivery to where all of a sudden everybody was able to provide content, not just the large content providers. And now we're sort of at the end of Web 2, where we've really brought in Enterprise 2 concepts, social networking, collaboration, multimedia, various things of that sort. Lots of automation, lots of personalization. And now we're moving towards sort of the more of the intelligent and semantic web concepts of intelligence in a network, augmented reality, sensor networks, mobile networks. And the world is becoming very small. Information is now pervasive, but all of a sudden we have this growing computational capacity that has never existed before in very smart devices talking to each other, doing things on our behalf, and very much merging the real world with the digital world in a way where all of a sudden we as computer scientists have in some sense failed, because we've always been focusing on sort of the engineering solutions, not recognizing at some pace, all of this market and consumer usage of this technology is going to catch up, where people are becoming more and more dependent on technology, but at the same time they don't want to deal with the complexity and the issues, and it needs to become more transparent. And so all of a sudden, as the real world is encroaching on the digital world needs to perceive the real world, and needs to start to adapt to more of the personal and social aspects, which means that engineers have to start thinking about how we can program our devices to be self-healing and to learn and to adapt and to do these various other things. So with this growing digital intelligence, we're running into the problem that we have this information overload. There's just way too much information. There's too much garbage out there, and yet there is vast amounts of absolutely phenomenal information out there that, if properly personalized and correlated and targeted, can start to enrich our lives. So the connected world has moved beyond sort of our IT infrastructure, IT corporate enterprise solutions, into the everyday life. And as I just explained, people have no desire to really to deal with the technology. It has to be presented in a way that the information is somehow processed in the back end and only given to us the way we need it. And nowhere do you have to look. You don't have to look too far beyond just considering what Apple did with Siri. It's just got the whole industry in a frenzy trying to figure out what Siri is, and not recognizing that for the most part it's all technology that was brought into service through a combination of cloud computing, some rule-based capability, like if this then that capability, like Yahoo Pipes, with some server, some data mining, and a chatterbox on the client that enables me to do voice natural language processing and interface into an API that can basically serve some of the things like facilitate interface to likes of Yelps and Google Maps and various things of that, calendar, etc., things like that. So that's really where things are heading, and everybody's trying to figure out now how to make that broad across everything. So the other part is sort of what I would call human-computer co-evolution. Back when I was here, that's the CDC 500 that we used to punch cards on, and used to cause havoc with interesting hacking things. It was basically one mainframe computer for lots of people. And then it wasn't too long before we were able to put one IBM PC on everyone's desk, two if you had one at home, if you were quite fortunate. But now we've moved into a place where we now have many computers for everyone. I myself, I can't even count how many computers I have. iPhone, Android phone, iPad, MacBook, Mac Air, my work computer, my home computer, not to mention all of the embedded devices. We're going to have 50 billion plus devices in a very short amount of time. Most of them are going to be part of the Internet of Things and a smart connected world. We already have, on our behalf, smart cars with dozens of co-processors sensing the roads and understanding the environments and doing avoidance prediction. We have, all kinds of embedded intelligence that's coming around. All you have to do is look at the state-of-the-art intelligent appliances and recognize that pretty soon your stove is going to be talking to your refrigerator and reminding you that you left the stove on or left the refrigerator open, or that you should buy more groceries. And so all of these things are getting to a point where it's not so much about the individual products, it's about this computing ubiquity, where all of these things will start to have to talk to each other. And when you go back to my slide about the web evolution, the problem with the Web 2 is that Web 2 was really designed for content delivery. It wasn't, and not even that many. It was designed for client-server kind of content delivery. We're now at a point where the web has to become not just human consumable, but machine consumable. So we're looking for restructuring information on the web and delivering it in terms of content delivery network, where you don't care where the data is, but you go into the network and the data is in the network, it's distributed, and it comes to you not from a server, but from cached information in a cloud, in order to reduce, not in a cloud, in the network itself. And I'm talking disks or routers with disks to optimize content delivery and be consumed not just by your web browser, but be consumed by my smartphone, who's running not an application, but who's running an agent who recognizes that I'm in this room, and based on a context decides that it is important to remind me that I'm going to have dinner with my colleagues, and I don't have any cash, and I better go to an ATM. And by the way, there's an ATM, and it already loads the map and tells me when you finish, go there, pick up the money before you go to the restaurant. And the web is just not designed for that. At least it's not really readily available. But that's not the only problem. There are other problems. The other problems is that the enterprise is maturing, and the CapEx, OpEx cost of building enterprise solutions is basically broken. And there's a huge effort to move IT into ICT, which is information computing, communication technology, in a sense that it's no longer cost effective to have enterprises build all of the solutions in-house. They have to leverage public services. So we're getting into this hybrid kind of inner cloud back-end services being provided by other service providers. And part of that is that information is no longer just contained in a sort of secure perimeter secure environment within an enterprise. It spans the security domain. So I am now and when I say I also mean my devices cross all of these different domains. They're very contextual. So it's no longer the case that I have to think about the company interest in security and intellectual property. I have to also think about the privacy of the user and the information that's on my devices is being shared. And I also think about the interest of the device. What is the device playing roles on my behalf in all of these different contexts, and how can it leverage the content from the web in a structured way? So the enterprise, for instance, now, and there are many problems. I'm just touching on some very few to illustrate the need for trust. 80% of the mobile professionals will use at least 2 personal devices in a business. It is to the company's best interest not to buy BlackBerries and customize restricted devices to do certain tasks, but instead to allow iPads and Galaxies and Android phones with all of these sensors and applications and devices to be used in the corporate environment. And so the sort of static and perimeter-centric security policies have to really consider how that device interoperates within my control, so under my control, but also the corporate control in a sort of a kind of a multi-tenant, multi-domain information. And yet, as I keep alluding to, one of the biggest problems is this rising, this need to create an awareness of the real world from the digital world. We're going to start to see Wi-Fi routers that give you hotspots to connect to something to get to internet become local environment aware. So when my device connects to this router here, this Wi-Fi, my device can ask the router, say, by the way, where am I? And what can you tell me? And it's going to say, well, I've got a bunch of sensors around here, and I can tell you who's in this room. I can tell you who the people are, and I can tell you, give you access to their public calendars. I can, I do different things. And so as my device moves from one hotspot to another, the intelligence in the embedded space and the sensor actuator networks that are surrounding it can be coupled with this to give you a lot of environmental perception. So you can start to do very rich local sensing and perception of the environment. You can start to write generic applications to sort of adapt to the different environments and learn from your behaviors. You can start to do sort of this ambient intelligence in terms of understanding the space and use it to sort of enrich your life without having to deal with the underlying technology. So in all of this, there is a problem. So I got involved in corporate R&D's strategy and planning groups, and we looked at many different, what I would call global trends, and all of these different wonderful things like augmented reality and big data and data minings this and that, or personalization that, or intelligence this. And in all of these things, there was a common theme. Sometimes we miss the most obvious, which is you can solve the very interesting hard problems, but occasionally you have to go back and revisit something that you missed. And one of them is that what's missing now is trust. You cannot really merge the real world and digital world if you don't incorporate one of the human's most fundamental intriguing, which is trust. So we need to do a sort of a paradigm shift. And so the paradigm shift I would define in two very simple principles. The first principle is that currently we have a client-server model. Whether it's peer-to-peer, client-server, doesn't matter, cloud, we have a hardwired relationship between a client and a service. We have a membership in that service, so there's access control and logging in and security and all that kind of stuff. Totally irrelevant. The problem is it has what I would call a blind trust built into it. It doesn't question whether I should connect to the Purdue network. You simply accept it. So the trust is implicit, not underneath your control. And the same way, the server responds based on your access control and roles. And again, there is no dynamic trust or nature or whatever. The paradigm shift is that it would be very simple to introduce fundamentally a trust network, a trust concept, where before I do anything, and think about this ubiquitous computing world, this multi-device, multi-domain environment where there's all this intelligence, whatever, you can no longer have blind trust. You have to be able to, at every given instance, no matter how many times you've been there, ask the question, should I trust them? And if the answer is yes, then you do the connection. And that's and reciprocating, the server should say, hey, wait a minute, is this the guy still the guy who it is? And you realize very quickly that there is a contextual role, there's kind of a contextual environment that comes into play, because I may not be the same person all the time. Right now I'm standing here as a computer scientist, technologist, whatever, but I can play different roles. I can play a role of, well, actually, let me get to that later, because it'll be more appropriate. So let me just jump to the second principle and then get back to this example later. The second principle is that we have to derive trust from sort of performance and beliefs, not from trust values. So if you've studied anything in digital trust and trust networks, it is an extremely rich space. There's hundreds and hundreds of papers looking at any different kinds, but most of them boil down to having some kind of a trust overlay network with trust scores. And you try to derive trust from, if I know Chris, and I trust Chris, and Chris trusts Dan. He's going to hit me. It doesn't necessarily mean that I trust Chris or that Chris trusts me. In other words, trust is not transitive, right? And so you realize it's not a question of do I trust somebody and do they trust somebody else? It's why do they trust them? And if I understand why they trust them, it's not do I trust him, it's do I have a belief system that can apply that reason for the trust so that I can now trust Dan. And so we're going to talk about that. So what is trust? Trust is contextual and granular. It's contextual because, as I just alluded to, I play many different roles. And based on that role, the kind of trust that I'm looking for will vary. If I'm a father with my son, I may question the trust in a park at night in East LA. But if I'm with my motorcycle hobbyist friends, heck, I'm going to enjoy every minute of it, right? So asking do I trust to be in that park at night depends on the context that I'm asking it, both from the truster and the trustee. At the same time, the trust is not singular. It's not do I trust them, it is granular. What part of this relationship are you interested in? There are many different aspects to that, and I have to be able to break it down into contextually into the granular points. The next thing is that trust is belief-based, as I just alluded to. I'm a trusting person, so if I meet you for the first time, I will put you on a level of a friend, and you have to violate my trust before I reduce that trust. On the other hand, somebody else can be more of a distrusting person. If they meet you for the first time, they will usually not share any information, they will not shake your hand, they will kind of stand back and see if you're going to attack them, and you have to earn their trust. So there are many aspects of trust, and I'm only touching on some very few to illustrate some of these problems. Finally, the trust has to be continuously re-evaluated, as I just pointed out here. How do I make these decisions about trust? I have to be able to take some environmental variables and constantly analyze them based on my trust belief. So This brings us to how do we formalize trust. Trust today, it does exist, and it's growing in many places, but it's very silo and service specific. The most general is sort of the public key infrastructure that creates a static web of trust. And it's all based around certificates, signed certificates and double signed certificates and trust authorities and identity authorities and all this wonderful stuff. But it's designed specific for security and encryption. And in this case, it's completely worthless. It doesn't help us because it doesn't answer the question of dynamic, belief-based contextual trust. So there's been a lot of work. Trust is sort of entered into almost all of the major services. Amazon averages product ratings based on customer reviews. And if you go down the list of where trust is today, it is either burned into access control and corporate security measures, or it is more in a public domain on the level of reputation rating and recommendation engines. But even that is completely worthless. When I go to Yelp, as I'm sure you do, and you see a ranking that says this restaurant is 4 out of 5 stars, it's completely worthless. What that tells me is that majority of people like the restaurant. But it doesn't tell me whether those people are vegetarians or meat eaters, whether they like loud environments or noise or quiet environments. It doesn't tell me if it's during lunch or at dinner. What I'd like to know is, given who I am, giving my context, and giving the situation that I'm interested in, do I trust to go to this restaurant versus do I go to that restaurant? And so that kind of trust is not really what we're looking for. And yet, those kind of things are in marketplaces, news sites, job sites like LinkedIn is another example, right? How do you know what is trust in LinkedIn? All you have to do is see how many people, what kind of people a person has a relationship in LinkedIn, but more importantly, what kind of recommendations and kind of reputation statements they say about that person. And so you have to sort of mind it yourself, analyze it to understand whether you, in your case, you would trust that person or not based on what other people say. So what is our approach? Our approach is to try to formalize trust as a sort of contextual, granular, and belief-based generalized trust model. Now, this has been attempted in the past, and there's a lot of interesting work being done on it. So it remains to be seen whether this is even doable. As I was in Stanford at the WTO group, the Work Technology Organization, talking to a bunch of social scientists, and after patient listening to my pitch for about an hour, one of the most senior person there stood up and says, if I can be rude, why the H would you ever want to do this? Right? And he was right. It's a very difficult thing to do, and it's very hard to formalize, and it's not clear. But I think the time has come, and I think we're very close to making it work. So we need to define a trust overlay network that is deployed both as sort of this decentralized and federated system of trust brokers, and as sort of a peer-to-peer agent architectures where all of my devices can mediate trust on my behalf and communicate with each other without going to a centralized authority. We need to create mechanisms for incorporating feedback loops, because it is the feedback which ultimately defines how the system learns. Because the important thing is that in this kind of a trust network, especially for teaching our devices to be more intelligent and make intelligent decisions and mitigate risk, it cannot depend on me actively ranking every decision that I've made to teach it whether it should improve or remove trust. It has to be autonomous and in a background based on my actions that are mined from the responses. So in this sort of perceptual world this perception mining world that I described earlier, the various sensors can detect and analyze my behavior to see whether my trust or somebody else's trust that I have has been violated, and use that to basically drive the dynamic nature of the trust network to maintain the dynamic trust necessary to make those decisions. And finally, we need to utilize public recommendation and reputation rating agencies to learn and compare this information, and more importantly, do it in a way that the trust algorithms and the metrics that are being used are, in some sense, variable or modular, because ultimately it'll take some time for the system to stabilize and make things work. So let's get into some detail here. So when I talk about trust, we first have to talk about sort of the contextual representation of an entity. Now, when we talk about an entity, we're not talking about people anymore. We're talking about people, places, or things. We're talking about theory. Do I trust the evolution theory? Do I trust the Bible? Right? Do I trust my left foot? And so the important thing is, contextually speaking, we need to solve the problem of how do we describe and identify everything on the internet for which trust can exist, and it can somehow be related to a trust on the network. And you recognize that the OpenID and all of the stuff that's going on is highly broken. Because how do I have OpenID? I subscribe to a service provider like Google or Yahoo or the OpenID organization, and they give me an email address. And from now on, I am identified by my email address. But it's not granular enough. So how do I create a trust between me and that email account? If my georgiavanacek@gmail.com is me, then how do I have trust with gmail.com? I can't. So you're starting to see the problem. The context is basically the truster, which is me trusting somebody else, needs to represent contextually sort of not only sort of these attributes in terms of names and values, and for which we need a more standardized taxonomy for the names and a structured representation for the values, and have some kind of an ontology to represent that so that I know what you mean and you know what I mean. But we also need some kind of a self-description capability so that instead of being a tuple, it's a triple, giving me either a URL or a URN representation for some standards, so that if I take your attributes, I can look them up and somehow through this semantic web or some kind of ontology, I can understand what the meaning of this attribute is, right? It has to be self-describing. And so we define this contextual tree. I play many different roles. I have many different contexts. If it's a device, it's more about configurations or structure. But at any given point, there is a set of active contexts that represent me in different situations. And there are events that come from the environment which will change the context. So I'm not the same person all the time. And how do I go from one to another? Well, certain events have to trigger that, and that has to be represented. A trust relationship, then, is this concept of taking two contexts from two different entities, me in a particular role and a high school in a particular role. And if I want to answer the question, do I trust to send my kids to one high school and to another high school, I don't do it by looking at what people think in terms of trust. I look at the performance in the sense that the trustee at this point, as a context, has to collect some information, like the number of students that enrolled, the number of students that graduated, the number of students that dropped out, the number of students that got funded, the number of students that went abroad. And based on all those statistics, that is the context. Now, the trust relationship is not a trust value. It's not saying, do I trust them or not? It's saying, me as a father has a relationship with that high school, and that trust relationship is this dynamic information set of attributes that take some of these contextual environmental attributes and map it through a function that basically scores it. So what I'm talking about is the relationship is interested is what's the percentage of students that graduate? What's the percentage of students that drop out? And it's to basically normalize all this complex data into simple alpha values from 0 to 1, so that now I can say, what is the score on the graduation? And when I compare two high schools, I compare the two high schools based on what their scores are. But that's still not the trust, right? Before we get to that, the trust overlay network is a space. That's part of my problems of working with Chris here on geometric modeling. I think of everything in terms of geometry. So it's this parametric space where you have entities, context, and time, right? And so you get these cones, and you've got these arrows between them. And so there's this parametric space that has some pretty interesting properties, but that's for a different talk. So the trust relationship is this is this set of attributes that basically scores the context from the trustee and provides me with a set of, like I said, ratios, like in this case, graduation ratio being 0.87, and having some reference to a schema or ontology that can tell me what that means. So in order to derive the trust, I need a belief policy. And what a belief policy is that for every one of these scoring attributes, I need to have my own understanding. Go back to that slide where I was standing next to the guy who doesn't trust. Okay? So in some case, do I trust the high school that has an 80%, that has a 70% dropout rate? Well, if I believe in public education, not that actually that's a bad example because actually it's higher, I may have a lower belief in what's acceptable than if you're paying $50,000 to a private school where, for whatever reason, they can guarantee 99% success, right? So my belief versus somebody else's belief is now a value that provides the thresholds on where the actual scoring values fall. And so ultimately, the answer of trust is not, is it 0.98, but is it fit within my belief system, which is nothing more than just simple thresholding. And so now if I look at it at high school and I look at that relationship and I see those 15 different scores, I don't care about some of the sports and I don't care about some of the, after school activities, so I can ignore those. I can take a subset of those scores on that relationships, apply my belief system, and if all of those scores are above my belief threshold, then I will say I like that, I trust that school, and I don't trust that school. All right. So I'm not going to, because of shortage of time, I should probably move on. But there is so then there is the question if there's a direct relational in a trust network, I can just get it directly from that relation. If not, then I have to deduce it. So if there is no direct relationship, I have to look at sort of other relationship with that entity, the trustee, and try to derive from it. And I'll skip that because that's probably not important at this point. But general determination of trust gets a little bit more complex. Consider somebody answering a phone. Before you answer the phone, you always ask yourself: Is it a telemarketer? Is it my in-law that I want to talk to? Is it my ex-girlfriend, or is it somebody giving me lots of money, or is it a call that I need from my sister who's in a hospital and I absolutely need to answer? And if there's only caller ID, you have the first thing that you want to do is you want to establish a relationship and ask, do I trust this caller and do I want to talk to him? That's another example, right? Kind of oversimplified example, but it kind of fits the whole overall model. So how do I do that? First thing I need to do is I need to determine I need to take the context and I need to determine the identity. So from the caller ID, I need to go and find the identity. So if that caller ID is associated with the context and I can look it up in terms of context network, then I can find the context and say, oh yeah, that's this person, and I can know everything about it. If not, on the other hand, then I have to go to some kind of external identity like my directory and try to map the identity, the contextual environmental information into something like in a directory or Outlook or whatever, and then map it back into it. Once I have that, then I look up the relationship and either get it explicitly from the explicit relationship from my prior involvement or try to infer it from some other mechanism. And at the same time, I may want to go and allow my Siri or other agents on the phone or my device or whatever to go and mine data on the web that's publicly available to try to infer that information. And all of that can happen simultaneously, and then from all of that I can then ascertain this trust, right? So it's not as simple as just looking things up. It's something that you have to do quite a bit of work. So with this, I hope to kind of leave you with this understanding that trust can be formalized. And if you sort of think about this particular trust model and the way that you represent the relationship through scores and the way you apply belief systems, it is something that can be implemented in a sort of a trust overlay network where this information, the contextual trust indices and some of the scores, are distributed in these overlay networks, embedded on some of the trust agents and some of the trust brokers. And they're collecting all of this information from the environments, monitoring what's going on, and then allowing your personal beliefs to go into that and map it into a very simple Boolean question where when you have all of these different situations, like when I'm driving home and I'm opening the garage, do I trust that the door will open and that or that somebody's not going to be in there? And if you knew that you had sensors in the house that provided all this information, you could ask that of the house, right, before you actually open that garage, or before you went to the website and got infected with the virus. You can go to, ask the question, do I trust that website, in terms of finding some kind of a whitelist or a blacklist on a network that would reduce the trust and increase the risk and tell me you shouldn't do that. So it turns out that, as I explained before, there are many services right now that are coming together that with the first paradigm that I described, with a very simple modification of how we code programs, and this can be modified in our socket APIs. We can have this additional level of trust introduced that will really start to address a lot of the sort of security and policy issues that are still keeping us from generalizing some of these problems. So saying that, I need to leave some departing thoughts. First of all, and I'm not going to go through this list because we can spend a whole hours, and it's more of a philosophical, sociological kind of an issue, where there are these grand challenges in formalizing and deploying the trust systems, like avoiding overconfidence in what we do when we build systems, and we have confidence in the systems that are out of sync with the real world and the risks that are the consequences of the overconfidence, and understanding the limitations of a model, in a sense that it doesn't matter what kind of a model we build, it'll never be fully in sync with the reality. And part of it comes from my paranoia, from the work that we did in rigid body dynamics and sliding blocks off of a table and asking the question, is rigid body dynamics really showing us the real nature of the world, or is it just an artifact of the algorithms and the data models? Nowhere is it true than in trust. Avoiding model complexity by minimizing nuances and obscurity. Sometimes systems get so complex that they have a nature that is not understood, and at that point you get artifacts that are quite dangerous. Anyway, there's a number of things that you can think about. Foremost, confirmational bias of creating something that you want to see as opposed to something that you need to get from the system. And clearly these are the things that have to be thought about once such a formalism is created and products are built around utilizing it. There are many benefits of trust, right? And I talked about some of them. First of all, it will become tangible, something that you can control and exchange and draw upon. There's some of the important things here are, which is not quite as evident, is ultimately it'll allow us to socialize a lot of the IT technologies, and in fact almost all technologies. And so devices will have a better understanding of how they should communicate and do things on behalf of people, which would ultimately enable greater participation with more confidence and less risk. And it's basically all based around this need to balance the kind of trade-off between security and privacy, which usually one outweighs the other. And as I'm closely trying to address, it's definitely going to be crucial for the adoption of the Internet of Things in a smart connected world. So there are some open problems, specifically around, from the model and a computer science point of view, think about data structures and algorithms and protocols and the usual things. Well, I mentioned the identity problem. How do we, what standards do we use to identify entities on the internet? Okay, so there's a number of evolving standards around XDI and iNames and iNumbers, which are trying to address exactly that. and I'm not going to go into that. There's also the thing, how do we represent attributes in a way that contextually I can exchange information about my context without compromising my privacy. And that can be done around attribute-based cryptography, as I was taught today, where you can send somebody information and they can sort of unlock it, decrypt it only if they're within that particular context. I don't want everybody to know everything about me. So there's some private parts of my life that I don't necessarily want to share in a business environment. You may not get a job if people knew everything that you did. And so publishing all your contacts online is probably not the right thing to do, but has to be done in order for your devices to be able to consume it and do things on your behalf. And so there lies the problem. So who maintains and updates the trust context is also an interesting problem. Nothing that can be solved, however. I mean, we have the technology, just it's more of a business and deployment decision, not a technology obstacle. How do we define general and extensible taxonomy for the attribute names is an interesting thing. I mean, they can't just be simple name. There has to be some kind of a single, extensible, agreed upon ontology that allows different people to create different contexts, and yet ultimately the system know how to see what is common, what's the same thing. Share the scoring functions. How do we secure the trust overlay network, and how do we protect entities' privacy, which allows sharing. So and this is actually not all of the open problems, but these are some of the more important ones. So, in summary, I think the generalized trust systems, as I point out here, could be a very powerful tool in the future, especially around sort of autonomous systems, learning systems, and interoperable systems. One of the things I didn't really talk about is this whole thing around sort of this cloud membership. And if you think about it, and I think the industry is going to do the right thing. It's getting there, but it's still going to take some time. Is that right now you have membership in many different data silos. You have identity in Google and Yahoo and LinkedIn and Facebook, and they're all completely separate silos. There's some OpenID identity, but you don't own your data. It's out there, right? So it's the membership problem. What you really want is an ownership problem. When you die, how do you know what your digital signature is, and can you wipe it out? No, you can't, because you don't even know where your data is, or you don't even have rights to it. So there has to be a change from sort of membership to ownership, kind of like your own personal Dropbox, where you provide APIs to providers, and they can then consume and push data in and out, but you control it, and if need be, you can lock it down, and you can walk away with it, and so your digital signature disappears. What does it have to do with trust? Well, think about that. As part of that, this notion that you have these different memberships and you have these different clouds are using other clouds to distribute and move data between it. Just how that happens with you having any kind of a control over how things work is sort of the stress issue in this hybrid enterprise public service issue. So, without going into more details, as I point out here, we really need to start thinking more about the social issues and how the digital world interoperates with the real world, and we cannot ignore trust, because the only way to have us adopt technology that becomes transparent and deals with all this information overload and all this complexity is if we bring part of the real world and trust, which is something we understand, into the digital world, and we teach it to our devices and our smart computers to do things on our behalf. So the parting lessons is that it's time for the computer scientists to talk to the social scientists and the cognitive scientists and, dare I say, politicians, to really address this issue of formalizing trust on the future internet. Okay? So with that, I have 30 seconds left, and I can take questions.
Nobody has questions. Do you have questions?
Yeah,
Otherwise, I can ask.
about lying. I mean, you mentioned the quality.
You
You didn't press the button. That's all right. I'm giving you a hard time.
Okay.
Okay, now I gotta ask the question, right?
Now you can ask.
So you mentioned caller ID,
Yes.
but caller ID can be substituted with other information, right? So you can't trust it.
Well, and
So
that's something you have to take into account.
where is the
That's right.
feedback loop in your thinking to reevaluate the trust computation when somebody maybe lies?
So that brings up the whole issue of risk assessment, risk management. Trust and risk, as I described this afternoon, is two sides of the same coin. The higher risk you have, right, the lower trust you have. And so as you increase trust, you reduce risk. At least that's the effort of that. You cannot eliminate risk entirely. And you can never be 100% certain. The whole portion is, can you even begin to assess the risk and somehow quantify it so that you can make decisions? Because it's not so much about that one instance, fine, so I'll burn myself once or twice, but it's about sort of the feedback loop in a sense that if somehow or another that, because most in enterprise, for instance, phones are not just phones. They're part of IPPBX and Centrix and unified communication systems, and it's really all IP and everything going on. And so there's a lot of information being collected and funneled and filtered and secured and access controlled and recorded, stuff like that. So the system will know just based on my behavior. I pick up the phone, I'm like, dang it, I hang it up instantly, and I do it 3 times. Well, the 4th time it'll say, wait a minute, don't pick up that number because you're going to hang up, it's whatever, right? So maybe it won't even route it to me. After a while, I'll just get an email, like Google Voice, a little mail will appear in my Google Cloud that says, you got a call from this guy, but we just recorded it because we knew you don't want to talk to him, right? So that's the feedback loop. You build it into the IPPBX as a learning, statistical, behavioral learning, and adjusting mechanisms to respond to certain events. Those are all, go start a company, build it.
Yeah. I have a question actually, because because we have done a lot of research on trust negotiations and especially trustworthiness of information. So at the end, our conclusion has been that the difficulty is really building those functions which evaluate the trust, because those are really highly semantics dependent. Yes. And for example, there has been some very nice work by a group of people at Yahoo, and they were working on the problem of information credibility, which I don't know whether you have, so I wonder whether that's a different, but in any case, they were working on this problem. People get a Twitter message. Can I trust those messages? But the way they analyze it, they really look at the language which is used. It's very specialized for Twitter messages. And so the question, this paper shows you that you really need to do linguistic analysis to understand whether you can believe this message or not. So this means that at the end, it's easy to come up with a trust formal model, but the trust evaluation functions, those are the challenging ones. Well, so I wonder whether you have already class of applications that you have kind of analyzed for which you can come up with this trust evaluation.
So there's a number of applications, direct applications of trust. One is the trust as part of sensor networks and ambient intelligence. So if I put a lot of this ambient environmental processing on hotspots, you have to assume that you cannot trust any of the sensors, right? So somebody can spoof the thing, and the camera is really here, but it's really, it's the Mission Impossible. They put a little picture in front of the camera, and you're sitting there going, oh, everything's great, and there's havoc going on. So you need. That's one. Another one is to bring your own device in the enterprise space. And in these different trust-based contexts, you might have to apply different trust matrices and trust algorithms to evaluate that. In other words, I'm not saying that there's going to be a single universal general common mechanism. It will never
Yeah,
work
but
until we get sophisticated enough to where we can sort of modularly modify the trust with some understanding without becoming obscure and complex and
But I think that actually one ingredient which may be missing in your solution is that because we reasoned a lot, even looking about sensors on unmanned aircraft, can someone manipulate the environment? So the GPS senses the completely wrong value, and you can do that. You change the magnetic field and the sensors are all. But our idea at the end is that you need to give users some kind of trust score.
yes,
And allow users to do actions to, really acquire additional information so that they can say,
yes,
so how do we express those kind of policies or rules by which I can say, for me this is really crucial. I need to verify more, and therefore I can do additional actions like deploying an additional sensors, sending a human user to verify something. Because that at the end will be something which is needed.
right. So remember, this whole concept of introducing trust is not about a foolproof, guaranteed, zero risk capability. It's not to introduce security in a more pure sense. What it is to do is to say people are creatures of habits. Many things are repetitive, and there's a lot of contextual information that can differentiate the different contexts and situations. And you may get burned first time or second time or the third time, but the whole concept of this trust is that it is this self-adjusting learning network of trust that would give you some high level of confidence that the third or fourth or 15th time that this happens that you should do it or you should do something else. And it is that thing that we're striving towards. It's not. It's an added value. It's not a complete solution, but it's another part of the equation that is missing in sort of building more intelligent systems, because the systems cannot be discrete, finite, static systems. They have to be like people, more reactive to the environment and be more willing to adjust and learn. And that does mean that, when we think of algorithms, right, we as computer scientists always want to get the right answer. No, this is more about the non-determinism, and occasionally we don't halt and our brain goes into an infinite loop. That's okay. It'll happen to one, but it won't happen to everyone. Right? Hopefully.